This presentation includes a discussion of a study which investigated crosswalk design and driver behaviors at roundabouts. This study sought to answer several questions related to crosswalk design and configuration, which included: should crosswalks be located closer to the roundabout where vehicle speeds are lower? Or should crosswalks be located further away from the roundabout at a point where drivers have a better line of sight to the crosswalk and increased reaction time? Should crosswalks be oriented perpendicular to the approach center line versus perpendicular to the travel lane center line? Is there an optimum distance for a crosswalk from the circulatory roadway? Is there an optimum distance at the entry approach versus the exit? These questions and others were investigated through this research project. As part of the background information, we sought to explain some of the driver culture and pedestrian culture which may influence yielding. There are no comprehensive national studies on yielding rates and the actual amount of walking or pedestrian activity that occurs. So we collected information from a variety of studies on the yielding rate in various states, and then we looked at the percentage of trips that are made by walking from the National Household Travel Survey. And in this graph, the larger the circle, the larger or more number of observations occurred. So for instance, in Maryland, 394 observations were made compared to 139 in Florida and 16 in Nevada. And from this regression line and from looking at this, we can see generally there's a trend in the relationship between walking trips and yielding rate, where higher percentages of walking trip result in or lead to or are related to a higher yielding rate. So this tends to support the belief that the more frequently that drivers see pedestrians, the more likely they are to look for them, recognize them, and yield to them. And also, the more percentage of higher percentage of trips that are made by walking also supports the idea that people will tend to see themselves more often as pedestrians and therefore are more likely to yield to them. So several reasons that could be tied up into why there is this positive relationship between yielding rate and walking trips. But overall, we were looking to this to help describe that driving or pedestrian culture. For our study, we wanted to incorporate some of those, or to control for some of those cultural differences. So there was a desire to collect data at locations in a smaller geographic area. So we looked at 2 locations that have a fair number of roundabouts, so we could control or we could look for differences in the different geometric characteristics. We looked at Carmel, Indiana, and Hilliard, Ohio. In Carmel, Indiana, we investigated 76 crosswalks at 10 roundabouts. We performed 50 crossings in each direction, so essentially going all the way around the roundabout clockwise 50 times and then counterclockwise 50 times. In Carmel, that resulted in 7,600 data points, and in Hilliard, that resulted in 3,200 data points. As far as the overall results, in this table we can see the average weighted yield rate for each location, Carmel and Hilliard, based on the crosswalk position, whether they were crossing the entry, so as vehicles are entering the roundabout, or the exit, vehicles exiting the roundabout, the number of lanes, whether it's a single lane or a 2-lane roundabout, and the pedestrian's waiting position from the curb or from the island. So at the curb, the individual, the research team member, was crossing from the curb going into the splitter island, and then from the island, the waiting position would be that they were in the splitter island and then going to cross towards the edge of the roadway. Overall, Carmel had a yield rate of 10%. Hilliard had a yield rate of 19%. And we can see that those numbers vary by the crosswalk position, number of lanes, and waiting position. Generally, yielding rates were higher for entry crosswalk position, single lane approaches and crossing from the island. The variables that are included in this analysis and included in further model analysis: exit represents whether the particular location is the exit or entry approach of a roundabout. Lane, or the number of lanes at the crosswalk. Each of these are not included in the first 4 columns because each of the 4 columns are separated by entry or exit and 1 lane versus 2 lane. The numbers shown in the chart are the correlation coefficients between each of these variables and the weighted yielding rate that we saw in the previous table. Moving on to the other variables, island is the pedestrian crossing point, whether it's from the island or from the curb. DIA is the inscribed diameter of the roundabout in feet. RAD is the fastest path radius of the roundabout in feet, rounded to the nearest 10 feet. Off is the crosswalk distance to the circulatory roadway in feet. Off 30 is a categorical variable where the used for the crosswalk when the crosswalk distance to the circulatory roadway is less than 30 feet. Off 50 is another categorical variable where the crosswalk distance to the circulatory roadway is greater than or equal to 50 feet. ANG is the crosswalk angle in degrees, measured as the angle of deviation from perpendicular. REFW is the pedestrian refuge width to the nearest half foot. Cross W is the crosswalk width to the nearest half a foot. VOL is the traffic volume in the circulatory vehicles per hour. SLP is the slip lane presence, whether there is or is not a slip lane. And these are all correlation coefficients related to the weighted yielding rate. Next, we have models that are developed based on the analysis, including a full multivariable linear regression model with an R squared of 0.49 and a just R squared of 0.475, which includes the variable exit, which is going to control for whether it's an exit or entry. Lane, which is the number of lanes, 1 or 2. Island, this is the pedestrian crossing starting point. Island is 1, curb is 0. Off, which is the crosswalk distance to the circulatory roadway in feet. RAD, which is the fastest path radius in feet. And then the constant. There's also a reduced forward selection regression model with a similar R squared and adjusted R squared that's presented that does not include off and RAD, which controls for collinearity. And this model estimates that the yielding rate was 13.3% lower for a crossing at the exit versus the entry. And the yielding rate was 6.6% lower for a 2-lane crossing compared to a 1-lane crossing. And that the yielding rate was 7.1% higher for a crossing from the island versus from the curb. This study confirmed key findings from previous research that yielding at crosswalks that are located at the entry approach to roundabouts was greater than at exits. Previous research suggests this is likely because drivers decelerate at the approach and accelerate at the exit, so it's results in a higher likelihood of yielding. Our study also supported the finding that yielding at single-lane roundabouts is greater than at 2-lane roundabouts, and that yielding rates are higher when the pedestrians are at the splitter island than at the curb. Specifically to this study, at the entry crosswalk, the additional separation, when there's additional separation between the circulating lane and the crosswalk, so greater than 30 feet, when the crosswalk is further than 30 feet away from the circulating lane, this appears to reduce the propensity of drivers to yield. This could be related to higher vehicle speeds when they're further from the roundabout. So crosswalks that are closer to the circulating traffic have a higher yielding rate, although it is good to offset the crosswalk away from the circulating lane far enough to store one vehicle. However, in this study, that effect was small. At the exit crosswalk, higher yielding occurred when the crosswalk was further from the circulating lane, so the opposite as from the entry. This could be due to the speeds and the attention of drivers. So as drivers are exiting the roundabout, the further that roundabout is away from the circulating lane, the more time it gives drivers to change their attention from the roundabout and to the crosswalk. However, similar to the entry, that effect was small. So this study overall did not find any meaningful change in driver behavior based solely on the geometric design elements, which included distance, location, and alignment of the crosswalk. However, future research could target these elements more explicitly by controlling for other more significant factors that were found in this effort. Those include whether or not the crosswalk is across the entry or the exit, the number of lanes, and the pedestrian crossing starting point. Additionally, a higher base yielding rate may have resulted in different outcomes or possibly more statistically and practically significant results from the two locations that were studied in this effort. This research was funded by the Federal Highway Administration under TOPR 34, Accelerating Roundabout Implementation in the United States. The authors would like to thank the Federal Highway Administration for sponsoring this work, and specifically thank Jeffrey Shaw for his guidance throughout the project.